Hello everyone, welcome back to the channel. In this video, we will learn about how to Dockerize a Spring Boot server. This is in continuation to our last video, which was on how to Dockerize a simple Spring Boot application. Now, what is a Eureka server? It's actually a service which is used for service discovery, right? In a microservice architecture, whenever you have multiple services, you need some way to see like what's the IP, what's the port of a particular service and all. So that's where Eureka server comes into the picture. Um, but yeah, that's not the topic of this video. I'll have a separate video for that. Now going here, first the first step will be I'll run this without any Docker integration. I'll just run it directly. So just to see the project itself, right? It's nothing. I've just initiated a simple class with Eureka server command, and that's it. This makes this project a Eureka server, and I have already compiled it, and we have a snapshot.jar for it. First, I'll go ahead and run the snapshot.jar so that we can see what's happening here. Java jar, and this is the file path. So I'll hit it, and it does some things. There are some issues, etc. But we don't need to worry about that. All we need to see is how to Dockerize this thing, right? So this is the port that where it's running it. I'm going to see what's running here. All right, I'll go to localhost 8080. Right, so it's also web page to us. That's all I wanted from this Eureka server, just to give us a route and some response for a request, right? So this is a get call on 8080, and this is the page it serves. Now we need to do the same thing when we run this server inside a Docker container, right? So for that, I'll close this here. First step is obviously to create the image for our Docker container, right? So for that, we need to write some instructions which are part of Dockerfile, and I'll quickly read through these instructions. So what we are doing here, this is the first part. We are where we are generating the snapshot.jar essentially. So whatever is inside this target, right? This guy. So we are trying to generate it. So what are the steps? First of all, we are installing Maven because that's the package man we need. Second step is we are copying the source directory, which is this directory, which have all the code to the Docker container user slash source slash app directory, right? We pick up this folder essentially and we put it in on this file path in the Docker container. Same for pom.xml, this file, right? We are picking this file and putting it in user source slash app. Now, these are the only two resources we need to build up this image. So once the copy is done, we run our Maven command to package this essentially. So what we do, we run Maven dash f the path of our pom.xml, and we ask it to do a clean package of it. So this command will essentially generate a snapshot.jar file and put it inside app slash target, right? Because if you see this example also, right, there's a source directory, there's a pom.example directory, and when we do a compilation, when we do a packaging of this pom.xml, it generates a target folder within the root folder. Same will happen here. So user source app is a root folder where we have put down our source and our pom.xml. So this is where it will generate the target folder, right? And we'll put the snapshot.jar file there. So this was the part of generating that snapshot. Second part is actually running it. So this is the part that does that. So what we are doing, we are first pulling up a Java image, right? JDK image. Um, Then we are copying the our snapshot.jar file, which was generated inside user source app target on this step, right? We are picking it up, we are copying it from here to directly to user app slash eureka. This is the file name that we are generating, and I'll talk about this later. And then finally, we are describing an entry point, which is the command that it will run after the copy is done. So it's doing java dash jar and path to the snapshot.jar file, which is what we essentially did when we ran it manually, right? So the first step is creating the image. So I'll do a Docker build tag. I'll call it ARM64. That's just platform Linux ARM64. Now just to explain this, this is doing a build and adding a tag to this build. Whatever image it will build, it will add this tag to that image, Eureka server ARM64. And this dot essentially signifies where is our Docker file is, right? So in this folder, it's right on the top, so just a dot. And now this is new, right? What is it doing? So since I'm running this on an M1 chip, so the platform for this is actually Linux ARM64. So when I'm running it, I'll be running this image on my M1 chip, so I'll have to build it for that platform. Now you can pass in multiple commands here. You can also say something like Linux, AMD, and that will build it for an Intel chip, right? So I'll just skip it and I hit enter. So this does some steps and our image is ready. Actually, I have already built it, so it's picking it up from the cache, but that's a step. Now we will do a Docker image ls to get all the images, and this is our ARM64 image. I'll pick it up and I'll run it. Now, when running, what's essentially a difference, the main difference between running a server and a normal application is, for a server you have some port which is exposed where it takes in the request, right? So in our case, that port was 8080 where our Eureka server was running. So that's why we have mentioned it here, 8080. So when you're running your Docker image, when you're running it inside a container, you have to specify which port you want to expose it to, right? So in our case, Docker run -p and 87. Let me expose it on the machines 8000, right? Let's keep this thing as 8761 and 8080. So what this is doing, it's saying that the port 8080 inside the container should be exposed to port 8761 on the host machine, right? So what's a host machine? What's the container? So container is the Docker container inside which this image is running. So we have the server running inside our Docker container, and that server is running on port 8080 within that server. Now to expose it out so that you can directly go and in your browser you can do localhost 8 some port number. Now that localhost some port number is actually for your machine on which you are running that Docker container, but you have to somehow map your machine port to your Docker container port, right? So that's what it does. It maps your 8080 to the 8761 of your machine. And the next step is we give it the image name, right? If I hit it, right, it starts the server. It's doing something with it. Let's wait for it to build. And we can see that it has started it on 8080. Now this 8080 is the port of the container, Docker container. It's not your local machine port. So if I go here, if I do 8080, it doesn't give me anything because the server is running on 8080 of the Docker container. And what we have told Docker while running this command, we have told it to export that 8080 and proxy all the requests via 8761 of the machine. So if I go back and instead of 8080, I do 8761, it passes on the request to the containers 8080 and gives back the response. So that's how you run a server inside a Docker container. You expose your server ports, etc., and map them to your machine port. Alright, that's it for today's video. I'll pause it here. Thanks for watching it.